Welcome back to our machine learning series. In the previous lecture, we looked at the bigger picture of data preparation and saw how it forms the foundation of every machine learning project. Under that, we learned there are two main steps: data preprocessing and feature engineering. Today, we're going to zoom in on the data preprocessing part, specifically on a very common and important task: handling missing values under data cleaning. What is data cleaning? Before building a model, we must ensure that our data set is accurate, consistent, and complete. Data cleaning is the process of detecting and correcting errors or inconsistencies in data. As we can see on this slide, there are several issues that can affect data quality. Missing values, where some data entries are blank. Invalid values, like having a gender value as A instead of M or F. Misfielded values, where a value appears under the wrong column. Misspellings, such as Italy instead of Italy. Duplicate or non-unique IDs, and format issues, like inconsistent date formats or name structures. These types of errors are extremely common in real-world datasets, and if left uncorrected, they can cause major problems during model training. The challenge of missing data. Let's focus on missing values. Machine learning models cannot handle null or nan values directly, and here's the tricky part: there's no universal solution to missing data. The best method depends on your dataset, the type of missingness, and how much data is missing. Common strategies. 1. Dropping rows or columns. The simplest option is to drop the rows or columns that contain missing values. However, this isn't always a good idea, because it can lead to significant information loss, especially if many rows contain missing entries. So we usually avoid this unless the missing data is very small, say, less than 5%. 2. Data imputation. A better approach is data imputation, replacing missing values with meaningful substitutes. One of the simplest imputation techniques is using the mean or median of the non-missing values in that column. For example, in this dataset, one person's weight is missing. We calculate the mean of the existing weights, 55 and 60, which gives 57.5. We then replace the missing value with this mean. Pros and cons. This method is quick and easy and works well for small numerical datasets, but it doesn't account for relationships between variables, and it doesn't work well for categorical data. For example, you wouldn't replace missing city names with the average of other cities. So, while mean or median imputation is simple, it should be used carefully. We also have most frequent value approach. This method fills missing values with the most common or mode value found in that column. It's particularly helpful when dealing with categorical data. For example, replacing a missing gender with the most common category, or filling in missing cities with the most frequently occurring city name. This approach works well for small data sets and helps maintain consistency, but just like mean imputation, it doesn't consider relationships between features. And there's a small catch: it can introduce bias by overrepresenting the most frequent category. Next, we have the constant or zero-value imputation method. Here, we simply replace all missing entries with a constant value. For example, 0, or another number that makes sense for our dataset. In Python, you can do this quickly using the pandas command, df.filna 0. You can see this in the table on your screen. All missing nan values are replaced with zeros. This keeps the dataset complete and avoids errors when training models that don't handle missing data. But again, it should only be used when 0 or that constant actually makes sense, like when 0 indicates no value, no transaction, or no observation. But remember, while it's easy to apply, using 0 might distort your data distribution if the variable's natural range doesn't include 0. So, it should be used only when 0 is a meaningful default, like a no purchase or no attendance situation. To wrap up, so far we've looked at three main imputation methods: mean or median imputation for numerical values, most frequent mode imputation for categorical data, and constant value imputation when we need to fill all blanks quickly. Each method has its advantages and trade-offs, and choosing the right one depends on your dataset and the type of variable you're cleaning. Next video we shall look at how to handle categorical variables. Thanks for watching.